CRISTAL was initially formed to help support physicists at CERN in Geneva in the construction of the CMS detector for the Large Hadron Collider. And this was carried out largely in the period 1998 to 2003, whereupon the CRISTAL software has been used at CERN for a period of 6 to 7 years for the construction of the detector for the Large Hadron Collider.
When building one of the largest experiments for the LHC at CERN, scientists had a desperate need to make sure that at the time of operating the experiment, all the physical parameters of each individual component within each detector would be perfectly understood on the physics behavior to such a way that when we would study the result of the different collisions, we should be able to capture the physics and not only a signal. Consequently, we had to look for a database, obviously, but with tracking capabilities and at the same time a capability to be very flexible. So of course we looked into commercial products but could not find anyone suitable for our needs. Consequently, we decided to launch this big project that at the end resulted in something like 80 man-years of development that was done in 2 stages. The first prototype to sort of proof of concept, proving that we could effectively be able to build such a system, and the second phase, which was the one that actually led to the system that is currently in operation at CERN.
Now, the problem was that when construction started in around 2002, 2003, the full final design of the detector wasn't known. So those crystals had to be measured, but that data had to be put somewhere where later data and more advanced data structures and further construction details could be put alongside it without breaking it. The full construction lifetime of the detector was about 10 years. So CRISTAL was designed to be able to keep all that data, to integrate it all together in one place, which is quite a unique challenge, and it was quite difficult to do. The CRISTAL software was designed to meet these requirements of the ECAL detector, but it was thought while it was being put together that these concepts about allowing a very flexible means of production, basically a prototyping system, could be very useful for small, medium-sized enterprises and in fact in lots of places. It was designed to not be specific to ECAL components, to be about any object at all, which we call an item. This was completed in around 2003 and was spun off into industry then. And since then we've been involved in various research projects to apply the technology to analysis management. So people who are doing analyses on the grid can create an item which is an analysis which will go off and run on the grid and collect all their data in exactly the same way as a CRISTAL collected its data, bring it all together and allow analysis and querying to be run on top of that. Initially, CRISTAL was developed by a consortium of three bodies. There was CERN, there was the University of the West of England and CNRS, the French particle physics body. That development finished in about 2003 when it was spun off for technology transfer, and CRISTAL has been governed by the consortium ever since.
Currently we're using it in something known as the N4U project, which is for Alzheimer's. And clinicians, they have large image sets and they run large analyses on these image sets. The thing about CRISTAL is it tracks everything. So due to the fact that they run different analyses on these, since CRISTAL doesn't throw anything away and it logs everything by design, they're able to see how their analyses ran in the past. The scientific term for this tracking is actually known as provenance, where you discover the source or origin of something. At the moment, what I'm trying to do is I'm trying to add semantic web technologies onto CRISTAL, particularly focusing on making CRISTAL compatible with the whole linked data cloud available today. And one means of doing this is by adding something known as semantic provenance to CRISTAL. One of the reasons why I came back here is because I'm working on the CRISTAL-iSE project, and the company that's involved in that is M1I. They're based in Annecy in France, and they've been using CRISTAL for quite a long time now, since 2001 I think. They mostly use it for business process management solutions, BPM. There's another startup company as well, which is in Switzerland, which is in Geneva actually. They're called Techoledge, and they're mostly using Crystal for production line management. And I'm working with both of them to actually bring Crystal to the commercial world, as well as I'm doing the research angle with CCCS.
CRISTAL is a software platform that allows people to track things, and it started off being components of a detector, but now it can be pretty much anything that needs tracking. When a particular type of thing is defined in CRISTAL, it's given a life cycle which tells it how to behave, what data needs to be collected on it, who needs to act upon it. And using those principles, we've expanded it to running analyses, to building anything, not just detectors, but any prototyping that needs doing. It's very, very useful for prototyping, for making single instances of things and deciding how things are going to be built. And then when the life cycle is complete and stable, then it can be put into large-scale production, but still tweaked. The idea is that you decide how the software behaves rather than the software telling you how to behave.